Good morning. I'd like to give you some updates for the Chapter 4 lecture on carbohydrates. Please note that we're skipping Chapter 3. It's a lesson on digestion, and I feel that during the summer the chapters that we review give us enough on digestion and absorption. So we are on to Chapter 4. The reason that we have to eat is obviously to obtain energy. We learned about that energy is in the form of calories, which is actually a measure of heat. But we get the calories that we eat actually from plants. And plants get the energy that they need from the sun and carbon dioxide and water. So if you notice in this, the photosynthesis actually produces glucose and oxygen. So the basic building blocks of carbohydrates are called monosaccharides, which means one sugar. And this slide shows you the three basic monosaccharides. These are the building blocks of all carbohydrates: glucose, fructose, and galactose. So glucose is the body's main blood sugar. It's also referred to as dextrose. That is the chemical version of it. So if you go to the hospital and you have to get an IV fluid with sugar water, it's dextrose. When starches and other sugars break down, they primarily break down into glucose and fructose. Those are the most easily absorbed forms of the carbohydrates. Fructose is the fruit sugar. And galactose is not normally seen in nature, but it's found as a part of lactose. It is converted to glucose in the liver. So a disaccharide is when two of those monosaccharides get hooked together. So for example, sucrose is when glucose and fructose get hooked together through a bond right here. We have enzymes in our body that break these bonds so that we can absorb these nutrients. So for example, salivary amylase is one of those enzymes. When you put a cracker in your mouth, you actually don't even need to chew it to digest it because that salivary amylase starts to break it down. Disaccharides are also called simple sugars. So that question that you had on the chapter 2 exam, I believe, which one are simple sugars? Monosaccharides, disaccharides are simple sugars. Then the other form of carbohydrates are starches and fibers. Complex carbohydrates include those polysaccharides, poly meaning many of those sugars. Glycogen is also an example of those. These are the two starches that are found in food, amylose and amyloipectin. And then dietary fiber is a non-digestible part of polysaccharides, of complex carbohydrates. What's interesting is those simple sugars are one or two, and starches are typically many, like 3,000 or more monosaccharides hooked together. So this gives you an example, and it shows you the one little monosaccharide here. When you get into one of these is glucose. When you get into amylose, amylopectin, they're very big, and then glycogen is the storage form. Stored in the liver for use when you aren't eating. We have about 1,400 calories total of stored sugar in our body. Some of it's in our muscles, but we don't use that as readily. That's really used for kind of fight or flight muscle. So that glycogen is that storage form. Let's talk a little bit about dietary fiber. It's actually interesting. In dietary fiber, there's two types. It's called soluble or insoluble. Technically, our bodies do not break these down, but since soluble fibers are soluble in water, we do get some calories from soluble fiber. Okay, we tend to find soluble fibers. They are a part of gums, pectins, things like that in fruits. In the oatmeal is another great example, where insoluble fiber tends to be the bran of breads and whole grains, as well as kind of the structural part of the vegetables. Those are examples of insoluble fiber. The functional fiber, your book talks a little bit about this, which I wanted to bring up. Prebiotics are a type of functional fiber, and there's been a lot of talk of probiotics and the importance of that bacteria in your large intestine, because that bacteria is actually what kind of makes your immune system function. And so probiotics, which are bacteria that are found in things like yogurt and fermented foods like sauerkraut and tempeh, and even in beer, are good for the gut, and prebiotics are what feed those probiotics. And prebiotics are fiber, because that's what those little bacteria guys like to eat. This just gives you an example of what parts of the fruits and the vegetables and the grains are soluble and insoluble. Pectin is a soluble fiber, where cellulose in the skin is not. These outsides of the kernel of wheat are insoluble fibers. So let's talk a little bit about the differences in health. Why do we need to have those two different types of fibers? Insoluble fiber is what I kind of refer to as a rotor-rooter. It really, since it doesn't act in digestion, it pushes through the gastrointestinal tract and increases the fecal bulk, and actually moves food through your gastrointestinal tract quicker, which is actually a good thing because your body isn't absorbing quite as much in that way. When we get into the soluble fibers, like the pectins and the gums, the hemicelluloses, those actually slow the stomach from emptying into the small intestine. And what that does is that when food's in the small intestine, it's actually the insulin and the hormones that regulate blood sugar can act more effectively when it's slowly being entered into the small intestine. Another benefit is that actually soluble fiber can help lower blood cholesterol. So you've probably seen some of those commercials with Cheerios, which is made of oatmeal, oat bran, and that is a soluble fiber, and that helps lower blood cholesterol. I did have a funny story of a student who went to Burger King for lunch, and then she felt so guilty. She had remembered that I said that soluble fibers like oatmeal can help lower blood cholesterol, that she ate oatmeal for like her next 2 meals. She felt like that was her way to reduce the cholesterol in her body from her Burger King meal. Where do we find carbohydrates in foods? Well, this is a really important slide because carbohydrates are found in almost every food except for fats like oils and butters and meats. And a lot of people get confused in that because they think, well, wait a minute, isn't glycogen the storage form in the muscle? And if we're eating the meat, we're eating the muscle. But actually, after death, that carbohydrate breaks down in the muscle, and you actually don't store that in the muscle anymore. So, protein foods tend to have lower amounts. Obviously, animal proteins don't have any carbohydrates, but beans have quite a bit of carbohydrate. Nuts have a little bit. What about milk and yogurt? But this is the form of lactose, that milk sugar. This is fructose. This is very small amounts. Notice the carbohydrates way down here, okay? And this may be in starches or in fibers, so you don't absorb a lot of the carbohydrates from here. Most Americans probably get their carbohydrates from grains. I'm going to skip through the sweeteners. High fructose corn syrup, I believe there's a discussion post on high fructose corn syrup, so if you want more about that. What I usually tell people is that as far as avoiding it, I personally try to avoid all high fructose corn syrup. Studies have not shown any higher obesity rates in people who have larger amounts of high fructose corn syrup. I believe that the reason that the high fructose corn syrup increase use plus the incidence of obesity correlates is that Americans are just drinking a lot more soda, which is increasing their calories in general, and just happens to be that those calories come from high fructose corn syrup. So I'm going to skip through some of these other sweeteners. I don't believe there are any questions on the quiz about all the different sugar substitutes. I personally don't use sugar substitutes. Even there's natural sugar substitutes, things like stevia And then there's just regular sugar, which is things like honey and sugar and brown sugar and agave nectar. That's all regular sugar. And then there are chemical sweeteners, things like Splenda. And I personally don't believe in the use of sugar substitutes unless you're a diabetic and you're really watching your carbohydrate intake. So we'll skip through some of these. Stevia would probably be the one, if I were to use, I would use. So one of the things that's interesting about carbohydrates is that cooking actually starts the digestive process because you're softening that fibrous tissues. But really, the digestion starts with the amylase in our mouth. We have two types of digestion, chemical and mechanical. Chewing is the mechanical, and chemical is the amylase. Anytime something ends in this ACE, this means that it's an enzyme that's breaking something down. ACE breaking down amylose. Ose means it's a sugar or starch. The stomach has a very acidic environment. Most of the reason for that is to kill bacteria that's on food. And then in the small intestine, there are more pancreatic enzymes. So notice maltase, sucrase, lactase. These all break down those sugars. And then the absorptive cells in the small intestine can absorb the monosaccharides, and that monosaccharides gets moved into the blood, which is primarily in the form of glucose. Now, some people talk about lactose intolerances and in maldigestion. This has to do with a reduction in lactase that occurs naturally in our body. Most people, even with lactose intolerances, can handle up to a cup of milk a day. So a cup of milk at a sitting. And bacteria that predigest yogurt is actually a good choice because that lactose is mostly digested too. Skip through some of these, only have a couple more minutes. One of the things I want you to understand is that how quickly the glucose enters the liver, which then enters the bloodstream. And then what you need is actually you need the hormones like insulin to get that glucose into the body. Do you know that if you took all the glucose that we have in our blood, it would be less than a teaspoon? So that's how much sugar you have available in your body, in your blood, which is not very much. And I think about that a lot when I see people drinking like the big gulps or the huge Starbucks caramel macchiato, whatever, because I think about the amount of sugar that's in there. Okay, our body only has about a teaspoon in our body. So keep that in mind. A teaspoon is about 5 grams. So if you start to notice some of the grams of sugar in the foods that you're eating, you'll notice that it's pretty high intake of sugar. So why do we need carbs? Well, the most important reason we need carbs is for energy. Our red blood cells and our brain can only work off of carbohydrates, so we have to have carbs. The other benefit of carbs is that it'll actually allow protein to be more effective at building and repairing, which we'll learn about next week. It also prevents an action in your body called ketosis, which is when your body is in kind of a semi-starvation state. Let's talk a little bit about glucose regulation in the last minute. We use the liver to regulate the glucose that enters the bloodstream. And the pancreas secretes hormones that help regulate that. The most important thing to remember is that insulin brings sugar into the cells and decreases the sugar in the blood. Where glucagon is a hormone that is used to bring sugar out of from the liver, the glycogen that's stored, to get the blood sugar up. So when you wake up first thing in the morning and you don't have anything in your system, your body is using glucagon to break down some of that glycogen. We'll skip through these. This is a good piece of slide to review on the regulation of blood glucose. And in our last few seconds, I'm going to talk about the glycemic response and the glycemic index. There is also a discussion topic on this topic. I'm not a huge fan of the glycemic index because what it does is it measures food in how quickly that food will raise your glucose, but it doesn't measure it when you eat it with other foods. So for example, if you eat an apple, it'll raise your glucose higher than if you eat a Big Mac. I hardly believe that a Big Mac would be more healthy than an apple. So review these and review the dietary fiber, and I will talk to you guys soon. Thank you.